Hello, everybody. I'm Athina Petropoulou. I would like to welcome you to the second day of progress. Yesterday's day was devoted to faculty hiring and sharing experiences from all over the world. We had a lot of fun listening to all these experiences. Today, the day is devoted to tools that can help you succeed in academia. We'll start with educational tools, how to use technology for better offerings. Then we're going to talk about funding. As faculty, you need to know how to seek funding and how to obtain funding. It's very important. And then there's going to be a training session on how to conduct yourself when you go look for a job or when you become a faculty, how to conduct yourself, how to best present yourself so you have a successful outcome. And we will start with the first session that is on educational offerings.
Hi, thank you for the invitation to present at ICIP 2020, the IEEE International Conference on Imaging Processing. I want to start by apologizing for not providing captioning. The ones I can afford, those from Google Slides, do not fare well with my imperfect English. And also I apologize for the uneven background here. Again, my infrastructure doesn't allow me to keep a better, more uniform background. So logistics out of the way. I am here today to talk about educational communities of practice for an inclusive artificial intelligence. I am Laura Acion. I have a PhD in biostatistics, also a master's in public health from the University of Iowa. Essentially a biostatistician, but depending on who you are, you may understand better if I tell you that I'm a health data scientist. I am an academician, a researcher at the National Research Council in Argentina, the University of Buenos Aires. And then the next three items here that follow have some uncommon names that from my community involvement, my community of practice involvement. I ask you to bear with me. I will be talking about these communities in the rest of the presentation. So one of my commitments and work in communities of practice is to have been the first non-founder promoted to our Ladies Global Leadership team. I'm also the carpentries instructor and trainer. And finally, I'm a co-founder for Metadocencia. So it's no news for anyone that artificial intelligence presents unique opportunities as well as challenges for our societies, and that there are serious flaws reported about the way AI is developed and operates, posing serious risks to citizens, governments, and business alike. And particularly today, I am bringing one example that it's featured in this article written by Abeba Birhain and Olivia Guest towards the Colonizing Computational Sciences, that even if you are very familiar with the problems that AI has, I really ask you to read it because everything in it is very, very important. Essentially here in this tweet, Abiba summarizes it saying that computational and cognitive sciences are built on a foundation of racism, sexism, colonialism, Anglo and Eurocentrism, white supremacy, and all intersections thereof. And in this particular article, there's figure 2 here, where there's 3 pictures, 3 photographs from Abiba, and where she shows the effects of the Pixelizer, one of the latest apps with artificial intelligence, where you pixel an image and then the artificial intelligence decides who is behind the image. And as you can clearly see here, this artificial intelligence not only thinks Aviva is white, but also it thinks it gives us output that Aviva may not be a woman. So issues around fairness, transparency, and reproducibility mean AI can exclude and harm people. So there is a sore need of diversity in human resources behind artificial intelligence. There's likely what I should show you about the pixelizer would not have gone through to publication if a more diverse team would have tested, probably, or a more diverse data set would have been used for it. But we are having these products because the lack of diversity in the human resource force behind making artificial intelligence happen. On the other hand, there's also, we know, a shortage of human resources, such as scientists and engineers with the skills to create fair, open, and reproducible AI technologies. And as if all of this was not enough, most formal education is updating its curricula at a slower pace than artificial intelligence are put in production today. So today I'm bringing one way to try to solve this through inclusive communities of practice. So, and now it's where I start defining the terms that I used in my presentation. The first one, the first community of practice I came through, it's called Our Ladies, which is a worldwide organization that promotes diversity in the R programming language community via meetups and mentorship in a friendly and safe environment. And what do I mean by friendly and safe? Well, Our Ladies, one of the key features in Our Ladies and the next communities I will be presenting and all the conferences related to these communities is that the existence of a code of conduct, which is essentially some basic agreement on how the humans that participate in these spaces treat each other. And essentially it says, well, you will treat each other well. And if someone doesn't do that, you have a way to report about behavior. And so more people can intercede and make it safe for you and friendly. And it's quite basic. I mean, so basic that some people say, well, we don't even need that. We're adults, right? But it's a given that once such codes of conducts are put up and enforced, then incidents stop happening. I mean, they are really a lot lower cases when you have a code of conduct and the rules are set up front than when there's not. So, and what's Our Ladies? Well, essentially it's women and other minoritized genders helping each other in a safe and friendly space. And this, well, it has an educational side because Our Ladies has an informal educational side via meetups and given tutorials, teaching. There's a lot of open materials shared, high quality, and for free. But also there's networks and trust built, like pretty much like the GIF here, where one woman brings up another is showing here. And the network that this community has generated shows quite well because this is a post by David Yalva in BuzzFeed last year, telling the story of how a multi-million-dollar startup hid sexual harassment incident by a CEO, then a community of outsiders dragged it into the light. And this is telling about the platform that teaches data science skills called Datacam, whose CEO sexually harassed a member of the R community. And well, all the we try to protect the victim, and everything. So the Our Ladies community started talking about this, and then the rest of the community follow. And this couldn't be the sexual harassment couldn't be hid anymore, and it went public. This doesn't happen in communities that are not friendly and welcoming and safe. So, okay, you may be wondering, I am watching this because I am interested in education, and yeah, this is great. I'm all for gender inclusive communities in tech. So, wasn't this talk about education? Well, indeed, it was. It is. And through Our Ladies, I met the Carpentries. The Carpentries is another community of practice, educational in this case, that exists for more than 2 decades now, that has exactly the same principles as Our Ladies. It's safe, it's friendly, it has a code of conduct that is enforced, and where foundational coding and data science skills to researchers worldwide are taught. So, and it's nonprofit, it's open, and if you don't know it, it has a lot of materials, high quality materials online that I encourage you to look for. And it's not only a community of practice. Last year, it's a community of practice that is really linked to the academic world and to the research world, at a point that the Carpentries is featured as one of the few settings for best practices in education and training to be able to approach the problems of reproducibility and replicability in science that there are. And it was featured, the Carpentries were featured in this consensus study report by the National Academies of Science, Engineering, and Medicine last year. So Carpentries has a model, a nonprofit model, where main universities in North America, Europe, and other parts of the world are reaching out to the Carpentries to have the Carpentries steward how you teach these skills for data science and artificial intelligence to your students. So it's really big, and it's a community of practice. The same principles as I comment for Our Ladies. So, very inspired by the Carpentries, that before teaching coding and data science skills, starts to teach instructors who teach this how to teach these skills. So it's inspired by the Carpentries that teach how to teach before actually teaching data science skills. We founded Metadocencia. Metadocencia can be translated from Spanish to English as meta-teaching. And Metadocencia is an initiative that, teaches to teach, but in Spanish. Last mid-March, with the need to switch every class from in-person to online in Argentina, where we don't know when in-person classes will resume yet, some friends from the art community and I co-founded Metadocencia. Our mission is to nurture a community of Spanish-speaking educators by teaching concrete, evidence-based, and student-centered educational methods. We collaboratively develop open, reusable, and accessible resources to foster effective training practices. You may be wondering why there is a need for Metadocencia when there are so many open educational resources about teaching already available. Well, on the one hand, most state-of-the-art resources and communities around them are majorly in English or are English-speaking communities. On the other hand, English is an enormous barrier in Latin America. So Translations of contents are not enough for cultural responsible teaching. Meeting our learners where they are in Latin America means to not make assumptions about the knowledge of technologies such as Zoom, Slack, or Google Docs, and being conscious about internet access and accessibility differences. And this applies to engineering and computer sciences. It's not only educators at large. So in the last 7 months, we've reached over 1,200 Spanish-speaking teachers across 19 countries. The same strategy of teaching how to teach we implemented very fast in MetaDocencia has been implemented by other non-community-based initiatives, such as universities in the US. There is a huge need for this type of educational action, as this map is showing here. In academia, we most of the times we are in front of a class and nobody taught us how to teach. So it's really important, and it became evident when we had to go from the in-person to online setting. So what do I mean by teaching concrete, evidence-based, and student-centered educational methods? Well, what we teach in MetaDocencia, it's a 3-hour hands-on workshop where MetaDocencia's participants get to experience and practice simple and basic principles such as don't assume that your student has a computer, an internet connection, a peaceful space where to study, or good mental health. Ask them, communicate with them, particularly in this pandemic setting. Other things we teach is, well, don't try to beat a recorded video. We all know how difficult it is to get a video right from scratch. Call on people by name during your class. Don't teach alone. Try to have always someone with you online. So if your internet goes down, you don't leave your students alone. You don't leave your students alone when in person. Try not to, leave them alone online either. Use accessibility tools to help everyone. So nobody ever complained about having a font too big in screen. Or using high contrast, or using speaker notes in your presentation so they can be read by screen readers. Use breakout rooms. This is particularly easy if you use Zoom and lately Meet. Take a break every hour. This is one of my favorites because it's who can sit for more than 50 minutes and keep their attention intact, right? Even if you have a very active class, we can only take 1 hour at a time at most. So these are really simple, as you can see, like really kind of obvious kind of principles. But when you get to practice them on a hands-on workshop, they become easier to implement, and they come extremely helpful to have events and courses and classes online that are more participatory, that are more active. These are only a few. There's a lot more of these that we teach, and you may have already noticed that these are not only for online teaching. All of these also are great tips for teaching in person. And once you learn how to teach effectively, then you can really build up skills on data science and artificial intelligence. And all of this knowledge, it's out there for you in communities of practice that are friendly and safe. So I cannot recommend more to be aware of these communities and join them. So All of the metadocencias activities that I mentioned were possible thanks to our team's volunteer time and a $1,000 US grant from the Open Bioinformatics Foundation that supports our Zoom, Calendly, and other infrastructure. So in this link, you find all about metadocencia and how to contact us if you're interested in this initiative. And thank you very much for your attention.
Hello everyone, and welcome to the IEEE Progress Workshop. Congratulations on being selected for the workshop. My name is Waheed Bajwa, and I'm going to talk to you about the why and how of flipped classrooms from the perspective of equitability. Since this is a pre-recorded session, you might have some questions that are not addressed in the talk, and I encourage you to reach out to me in that case via either email or Twitter. So, the talk is about the fact that in universities, when we go and start teaching, and as you would become the future generation of these instructors, we assume that students are at a level playing field. But the reality is different from that. Students come from different socioeconomic backgrounds, they have different academic and learning styles, they are diverse in terms of their behavior. And we have to address that as instructors so that we can create some sort of an equitable environment for all students. And the point of this talk is that flipped classrooms is one such way, not the only way, but one such way in which we can achieve equitability in terms of socioeconomically, academically, learning, and behaviorally diverse student body. I have written a couple of articles on this topic which have appeared in various signal processing venues, and I encourage you to look them up for further details. This talk is going to cover only a small part of the discussion that exists in these articles. Okay, so let's get started with the idea that the medieval universities, for example, in the 14th century, you see one of the ways that instructors were teaching at that time in the picture on the far left. And on the bottom, you are seeing how the students were recording the messages. Now, of course, in today's world, we have changed these ink tablets to electronic tablets. But if you look at the picture on the far left, you see that today we are teaching in a very similar manner. We have an instructor, at least in the pre-pandemic time frame. We have an instructor who stands up on the podium, lectures to a hall full of students, and that's how the instruction is given to university students. Now, if we look closely at the picture that I showed you in the 14th century, for example, we see that we have students who are sleeping. We have students who are bored. And if we compare it to today's picture, we again have the cases that in lectures some students get bored. We have students who are filling up the front row and very attentive, and then we have students in the back row that are talkative and that are not paying attention. Now, one way to deal with this problem is saying that it's the students' responsibility that they pay attention, and if they are not doing that, there's nothing we can do. Or we can say that actually we can change our pedagogical style, because maybe the students who are not paying attention are because of various reasons that are outside of their control. And so the way we want to rethink the lecture format is for the following reasons. We believe when we are giving lectures, the students learn the same way, they behave the same way, and that they academically start within the classroom at the same level. But that's far from the truth. We have students who are theory-driven, and we have students who like to understand by doing problem solving. We have students who are fast learners, and we have students who are slow learners. We have students who wake up early in the morning, are fresh, and remain attentive, and then we have students who are mental drifters when they get bored. We have self-confident students who will raise their hand and ask questions during the lecture regardless of who is around them. But then we also have students who are very shy, who are self-conscious, who are afraid that the question they are going to ask don't make sense, and so they don't want to embarrass themselves in front of their peers. We also have students who love going to office hours, and then there are students who start the homework just before the night. But the most important part of this equation is this inverted pyramid that I'm showing you, where students who start taking classes in the 3rd or 4th year of their university degrees that are math heavy, we are building the concepts on top of, for example, calculus courses, differential equation courses, linear systems courses, and we believe that the students have this pyramid standing properly. But the reality is, for many students, the pyramid looks like the one on the right, because the students did not get A grades, they missed out on some concepts, and now when they have come to the upper classes, they are really struggling. And one way to fix this is by changing our pedagogical style. But why we haven't changed that so far? Why is the lecture format so ubiquitous around the university environments? And the reason has to do with somewhat of what I call law of teaching. That the learning outcomes tend to be inversely proportional to scalability of the teaching methodology. So scalability is how much time, energy, effort, space you have to spend to extend it to, for example, 300 students, 400 students, 500 students. Now, the lecture format is very good at scalability. It can scale to 400-500 person classrooms. But because of that, the learning outcome is lower. So if you want to come up with alternatives to lecture format, we should really think about formats that don't tip this scalability scale too much, because we want to be scalable because universities do not have infinite amount of money to pour into teaching one-on-one. So what are the alternatives to this lecture-based format? Well, one format which is very popular, has been written extensively, is the project-based learning. It's not that project-based learning where you give projects to the students throughout and you track them and they try to solve various pieces of the project. This has great learning outcomes. Students stay engaged, they learn a great deal. Unfortunately, the challenge is scalability. It's not very scalable. You cannot scale it to 100, 200 people classes. On the other hand, we have what are called massive open online courses, or MOOCs. Highly scalable. Sometimes you can have classes as many as 10,000 students, 20,000 students. Unfortunately, this does not create equity for the issues that we were talking about, because this only works for students who are very self-driven. So we have data that shows that most MOOC students who start do not finish it. It's not that they are not intelligent or smart, it's that there is no one-on-one or interactive discussion that can happen which will help them stay focused on the course. So what about the flipped classroom? Well, a flipped classroom is one that I contend can be scalable and it can have better learning outcomes. So what's a flipped classroom, first of all? In a traditional classroom, we have an instructor who comes and delivers lecture, gives the content to the students, and then the students go home and they contemplate on those things. They focus on doing the homeworks, other exercises, and learn in that way. And the expectation is if they don't learn, they will come to our office hours and ask us questions. Well, flipped classroom, as the name says, flips this concept on its head. It says the content delivery or the sort of lecture is going to happen during the home time. So the students are given videos that they are going to read, to watch. They are going to do some readings. And then when they come to the classroom time is focused on problem solving. There are various class activities that take place. Collaborative work takes place so that the instructor can figure out in real time what is missing in the broader understanding of different students and remedy that right on the spot. So there is an element of active learning in the flipped classroom also. So what about the scalability aspect? Flipped classrooms are known to have very good learning outcomes. There are a lot of references that have looked at this. But is it scalable? Well, traditional flipped classroom experiences talk about you have to design good quality videos. You have to have a student to guide or instructor ratio of 20 to 30. So definitely not very scalable. And you need to use some sort of an active learning classroom like this so that students can engage in collaboration. Well, this was the challenge that I faced when I was trying to move my signal processing classroom to a flipped classroom, where I had an average enrollment of 100 plus students per year. And the largest active learning classroom I had at Rutgers was 90 people. So the challenge was that, can I really scale up this flipped classroom? And the challenge, I am breaking it down into 3 pieces. So the challenge number 1 was creation of videos. So as any instructor will tell you, it's extremely hard to spend time on making videos like the one, in fact, I'm making right now, because you are always trying to make it better, sound better. What I did was, instead of spending a separate amount of time on these videos, what I did was I piggybacked on my previous lecture-based offerings. So in 2014 and 15, what I did is I recorded myself giving lectures to students using very cheap software and hardware. And then I stitched, sliced, and deleted some videos and uploaded them on YouTube. I did not actually make nugget-sized videos. Rather, I used YouTube table of contents to divide those videos into subtopics. What ended up happening was that for an 80-minute lecture, instead of 80 minutes, it took me about 2.5 to 3 hours per video. But because of that fact, I did not have to invest too much time on creation of videos. And my first flipped offering was in 2016, where I offered it to 133 students, 75% juniors, as they call it in the US, or third-year students, and approximately 25% seniors. That's a typo. This should be seniors. And this actually brings up an excellent example in what can go wrong when you are making videos, because one approach is that I actually stop the video here and redo this entire video again. But the other approach is that I acknowledge the mistake and I admit that this is not going to be perfect. We don't have to make perfect videos and move on. And this is what I'm going to do right now. So what did I get on the in terms of feedback on the quality of videos? It was that the videos could be made better, but students felt they get the job done. And so what I do now is, once I have the major repertoire of my videos, I now update 2 to 4 videos, upgrade them, improve them every year on the channel, keep on making it better. But I didn't spend hours and hours making very fancy videos, because it's not really the videos that teach the students. Yes, they will teach the students somewhat, but it's really also what you do in the classroom. And so far, these videos have been watched 970,000 minutes so far on my YouTube channel. This is what a typical video assignment within my flipped offering looks like. I have a course management system. So I assign, for example, for February 16th class, I assign, okay, here are the videos you need to watch. I tell them watch up to 10 minutes, 12 minutes, and so forth. So I've divided them into small nuggets. You see on my YouTube channel that the table of contents divides the video into subtopics. And in order to ensure that students actually watch the videos, I give them very small multiple choice questions that are so easy that anyone who has watched the video should be able to answer them. And I ask them to take this quiz before coming to the class. So if they haven't taken the quiz, that means they didn't watch the video. Or if they didn't watch the video and take the quiz, then they would not score well on it. Again, this is just meant as a little bit of a stick for the students to watch the videos before coming. And so that takes care of one of the challenges. Now, what's the second challenge that we have in terms of active learning? That's the student to guide ratio. What is the problem? Well, most public universities cannot afford one teaching assistant per 20 to 30 students. And the solution for us was we moved away from teaching assistants and moved towards learning assistants. Learning assistant is a concept where basically I hire students from a previous year's offering to act as peer instructors during the classroom. So in 2016 offering, I hired 5 instructors, and there was a Rutgers Learning Center that provided pedagogical training to these LAs. We paid each of these students about $1,500 per student, $7,500 for the course. Of course, this can be modified according to where the course is taking place, in which country, and so forth. The cost was not zero, but just to give you an example, this is $7,500 for all the students, or $1,500 per student. A TA at Rutgers University gets paid for a half a semester about $15,000 and for one semester or half a year, and then also there are fringe benefits and so forth. So it's really a tiny fraction of the cost of a TA. And when we did that, we ended up achieving a student to guide ratio where there were 6 of us, including myself and 5 LAs, in the room doing activities, helping the students, and the student to guide ratio was roughly about 20 students per guide. The third challenge, as we talked about, is that getting these kinds of classrooms for universities who do not have billion-dollar endowments is not easy and may very well be impossible for many universities. So can you do flipping in a regular lecture hall? Because you need to have these guides who are moving around in the classroom. And we said that we can do that if we have a large enough classroom. So this was a lecture hall with 400 capacity. Remember, I only have students about 130 or so. What we did is we basically made some rows. We told students they are not going to sit in the last rows. We had students sit in the first row. Then we forbade them from sitting in the second row. Then the third row and fourth row and so forth. So if you see, we have divided things into different zones. And a peer instructor basically, since this row is empty, can walk between this row and can talk to a person on the back and the front. So that allowed us to basically create some sort of an environment where we can talk to students without having that active learning format. The final piece of the puzzle, which I believe is very important, is the fact that you want collaborative activities. And so we wanted the students to engage in activities, problem solving, where they were built into teams. And one approach is you let the students build the teams. But if you do that, what's going to happen is the strong students are going to cluster together, weak students are going to cluster together, and some students may not have any friends in the classroom. So instead, what we did is we used a simple polling, and then based upon that, we tried to, the main factors we used was gender, race, GPA, and previous course grade, to build teams of 3 people where all 3 of them worked collaboratively together during the class time, and they received grades based upon their collaboration, and they were built into a team that had strengths and weaknesses so that people could help each other out. And so if you put everything together, a flipped classroom looks like this. You start with assigning YouTube videos, so 30 to 70 minutes per class. This is not graded. Then you also assign them reading. This is not graded. But then you tell them to take an online quiz, which is graded. Then in class, we start with the discussion of 10 to 15 minutes, go over the concepts, do some problems, and then after that, we basically do additional problems. Some of them are short polling questions and some are paper and pencil problems. And then some of those problems carry over to further homework. And then we have a similar thing which is called recitation in the US, or discussions or things like that, that happens in a different classroom at a different time. So this is the kind of problem that students were given in class. Some were very short, where I asked them, like, which one of these signals has higher bandwidth. And since 20% of the class responded incorrectly, I could immediately remedy what was going on right there and then. And similarly, we have other polling questions where students respond, and here the class was split. Half of the class thought one, and that gave me the feedback that, okay, there's something that I need to fix in the student's understanding right then and there. Here is an example of a longer question that students have to now solve it on a piece of paper with their collaborators, and then piece which is then graded. Okay. Now, does it work? It's kind of hard, but I am pretty happy with it. This is a chart. I collected data from the student attendance. And you can see from this chart that student attendance during my flipped classrooms, where the attendance was only asked in terms of they have to basically solve the problems, it was way above average. In particular, because the class was at 8:40 a.m. and anyone who has taught early morning college classes knows that students don't like it. My grades went up. Here is a chart of the grades. And since I'm running out of time, I will just say that student feedback told me also that students prefer the flipped version to the lecture-based version. There were students who did not like it, but part of their reason was they felt that it was keeping them on their toes every class. And so I'll conclude by saying that I believe the flipped classroom done in a manner that doesn't impose too much hardship on the instructor can be both scalable in terms of resources and can lead to better learning outcomes. So I hope you, as the future of our profession, will think about it, and when you become the instructor yourself, you will think of even more ways to make the education more equitable for students of all backgrounds. Thank you for listening, and I hope to hear back from many of you through either email or Twitter. Have a good rest of your day.
My name is Raj Rao. I'm a faculty member in the Department of Electrical Engineering and Computer Science at the University of Michigan. I'm also co-founder of a company called Minerva. I'll talk a little bit about a platform we've built there for computational textbooks to be able to teach computational anything, if you would. And that anything includes, at least in the context of many of you here, things like DSP, ML, machine learning, or data science. So let me preface this a little bit by kind of telling you a little bit of who you are. You've obviously seen me. I'm the guy on the right of your screen. I think before COVID, I didn't have a beard. After COVID, I have a beard. So I am the same guy looking different. My co-founder, who's also a staff member at the University of Michigan, is Travis. We've together built this textbook platform called Minerva. And today's talk is really in the context of trends in higher education. I want to tell you a little bit about what this new kind of textbook is, why we call it a computational textbook, and what I hope it can enable in terms of the kinds of conversations that the older generation of textbooks, if you would, couldn't quite enable yet. Okay, so let me tell you a little bit from the point of view of an author or as an instructor, if you would, is why do we need to create a new kind of textbook? Okay, so let's think a little bit about the textbooks that you've used. You know, generically, if you're a student or even as a faculty member, you pick up a textbook and often it's a printed book. What's nice about it from an author point of view is that a textbook often, my cat wants to say hello to you all, so hi kitty cat, is that textbooks allow you to have a kind of conversation between readers and the person who's written a book across space and time. And obviously, many of you working in signal processing or related areas, you've seen when you yourself typed some equations in the textbook. It's fun because it just looks beautiful, and a lot of the math of signal processing is just so pretty, and it looks even prettier when it's on a textbook format. The complement of a textbook that's been emerging lately, maybe you all have seen this, is something called Jupyter Notebooks. Okay, so let me show you a little bit of what Jupyter Notebooks look like. People have used Mathematica, have used these notebooks, but Jupyter is a new kind of way of authoring stuff in either Julia, Python, or R. And it basically includes stuff that looks like a web page. So you notice you can browse up and down, but every now and then in between, you see these code segments that you can run. So here's an example of something where Google on its platform called Colab has hosted this notebook. Someone has told me what the notebook is about. It seems to be about machine learning and cybersecurity. And when I run the code, that's the run button, as an example, it runs it, and the document is sort of living in a way that a normal textbook is not. Okay, so the point I'm trying to express here is that when one goes beyond printed textbooks of the kind that you're used to, computational notebooks have emerged in the last 5-6 years as a new way of taking the best of textbooks, which is the best of typesetting, but also the ability to show algorithms working with figures generated using live computation. So think about how textbooks used to be written. An author wrote it, they kind of had to figure out what sort of figure would look good in it, include the figure, and you see it. But in this modern way, with Jupyter Notebooks, you kind of run it as you go along. You include beautiful text, but also the figures sort of come up for free as you sort of compute. And it's a much more immersive way of learning because you can mix math and exposition and have inline code, and you're able to reproduce what the author did without wondering whether what the author did was something that you could code up on your own. There's a little tricky part though. As much as we have gone from printed notebooks to these Jupyter computational notebooks, there's a tricky part, which is when you look at a notebook like this, so this is again the notebook on machine learning and cybersecurity, you notice it's pretty long. It's pretty long. There's quite a lot going on in here. And it really is a notebook from the point of view that it's really a document that's meant for the person who authored it to remember why they did this. It is not a teaching document, because the reason I would say it's not a teaching document is because in examples of this notebooks, you can go up here and you can say, for example, runtime run all. And when you do run all, the entire notebook is basically being run. And as a student, if you're trying to learn, it's a little bit like watching a video of someone cooking. But what you really want to teach someone from an instructor's point of view is, well, how do you learn to cook? Okay, so the reason why we created this new kind of textbook is because even though we love the fact that books are conversational, they have these beautiful fonts, even though we love the fact that computational notebooks allow you to mix the best of books with live computation, what we don't like about these notebooks is this idea that if you run everything, it looks cool, but you don't really learn a lot. Okay, so we call this the run all, learn little syndrome. And we invented, if you would, this new kind of way of writing textbooks because we want more. So I want to tell you a little bit about what this greedy wish list, just in the general theme of trends in higher education, what I think is sort of, I hope, the new way of writing computational textbooks of the future for the kinds of courses that you, as an EECS student, have taken, which combines really the best of printed books, web pages, and blog, which means this beautiful typesetting. Right? It's not fun to read a book which doesn't look interesting. And you want to take the best of computational notebooks, which is the ability to intersperse text with real code that runs right there, as opposed to code that someone ran 5 to 10 years ago. Except as an author, we want more. We want the ability to be able to have this very dynamic experiential conversation where the material is revealed to you just when you're ready. And what I mean by that is really this important fact that maybe in the general theme of this conference you're getting a sense to, which is, I want to emphasize again, is everybody gets stuck somewhere, right? When you're learning something complicated, like in DSP, in Fourier transforms, you might look at the formula and you say, yeah, I get it. But then when you try to apply it, you say, oh, wait, I don't get it. And the important point in a textbook that we want to go beyond is in a textbook, when you see 300 pages, you look at it and you say, oh my God, I'm just in page 10, I'm struggling. How am I going to get 290 pages more? Wouldn't it be nice if the moment you're kind of stuck, you're able to intervene and call maybe the teaching staff, call the instructor in person, have the conversation so your concept is resolved, and then the portions of the book are revealed to you as you're ready. That's what we really created with this new kind of computational textbook, where we want to connect this learner to many of these pieces. And signal processing and EE stuff is really filled with it. There's a lot of little pieces that connect together, and when they glue together, like you do the Fourier transform of a signal and you see the frequency, something really cool, which I call mathemagical, happens. Okay, so the perspective is we'd like a textbook that combines the best of what's out there with this ability to have experiential conversation, the ability to personalize the book so that you can add content based on what you're seeing, and the ability really to reveal the subtleties of an algorithm via experimentation without worrying about page limits. Now, this is an important point because when you think of a usual textbook, the author has to think, if you've written a paper, you've had to think that too, is what do I fit inside a paper, given that I can only write 14 pages? Because if I write 50 pages, no one will read it. This new kind of textbook allows you to really dive into all the details of things you normally don't put in a textbook. Things like, wait, why don't you try this algorithm on this particular kind of data set, and look, it doesn't work because it doesn't really fit the model that's built inside whatever I'm trying to do. So why don't you explore it and see what about it is not working, rather than just giving everything that works always? Because a big part of being an engineer, especially a great engineer of the kind that we all hope you will become soon, is to be able to understand when things work, but also when things don't work. Okay, so all of these, when we combine our design focus in this trend, if you would, or what we hope becomes the new way of writing textbooks, is we focus sort of interacting with the student on showing them what's to be done instead of what's left to be done. And the key unit that we're kind of excited about, and we want to give you a chance to experience it as well, is a way of thinking about writing books that has this perspective of a codex. Okay, so let me tell you what this codex is, but just to dial back a bit, I need to give you what the codex is from the platform perspective. Okay, so a codex really, the word has a wordplay of code, which kind of reminds you of coding. And the X has to do, if you would, with anything else that is computational that you're trying to illustrate. Codex is, of course, the original kind of book, if you would. So it's a pun on sort of going back to the past by a new way in the future of thinking of books that have codes directly integrated into it. In our context, what it is that Codex is a self-contained, interactive, computational, instructional document. Okay, that seems like a mouthful. And Minerva really is this platform that we've built to author, distribute, and run codices. So think of it the following way. Minerva is like the analog of a bookstore. Codex is like the analog of a book chapter. Or equivalently, Minerva is like the app store, if you're used to downloading apps like Google Play or the iOS store. Codex is the analog of the app, okay? Now, what does a codex look like, right? That's an important portion, and I hope by the end of this talk, you'll get an opportunity to demo this yourself, that you'll really see the ways in which a textbook can be rewritten to engage you in ways that are hopefully more enriching, more fun, but also more immersive and go much deeper than a regular textbook would. So at some basic level, the Codex has things that you're used to. It has multiple choice questions. It has something which maybe not everyone is used to, which is programming assignments that are graded by the computer automatically. It has something which are called numerical threshold validation questions. So these are things like, imagine in DSP, you say, why don't you design a filter so that in the pass band versus stop band, you need to make sure that your stop band, the response is less than 0.1. Those are these threshold validation questions where you design it so that it meets the spec. And then, of course, you have things like free response. Like maybe you designed the filter and you said, wait, tell me, what does the characteristic of filter look like outside the pass and stop band? Okay, let me show you a little bit of what this looks like. You'll get to play with it too. So when you log on, yours will look a little bit different than my interface. But when you log on, you might see a codex which looks like this. Okay, so I'll have you play with something which is like Introduction to the Julia Programming Language. So when you open it, I hope you can see it looks a lot like a textbook. You see a table of contents, but here's where it starts looking a bit different. You notice that when I try to click on sections 3 to 9, I get this, stop sign looking thing. And it says this section is not revealed yet. Progress further through the codex to reveal it. Okay, what does that mean? You can read some of it, and just like before, you can sort of run stuff to be able to do it. But here's the important instructional, but also narrative aspect of writing a textbook this way. So you notice there's some portion of text, there are some portions of code which look a lot like what we saw in the Jupyter interface. But here's where things get different, is there is the first multiple choice question which punctuates everything in the Codex. So as an example, the goal here is to be able to understand something about variable types. And if I were to, for example, put the wrong answer, it'll say try again. If I were to put the right answer, then it says it's okay, and the next section of the book is revealed. In this example, if I put the right answer to, the next section is revealed, and you keep on going all the way till the end until the stuff is done. Okay, so this is the part where we're trying to emphasize the design philosophy, which is that you just focus on trying to understand what is being done. If for some reason any of these concepts are not clear, you call your instructor, and the instructors and the teaching staff are really there to help you. Okay, so this is this example of a Codex demo. From an instructor's point of view, there's a couple of different places where I've used this in my own class. If you go to this website down below, I won't say much more. You'll notice various codices on different kinds of machine learning algorithms. Here's a list of topics. These are codices that I use in my class on computational machine learning and data science. And the real perspective of authoring things this way, which I really hope many people start authoring this way, is that it focuses on linking this concept together in terms of the math and code. So students really learn by doing. And I think this is a trend that's here to stay, because in the older version, echoing what Waheed talked about in his talk about flipped learning as well, the old-fashioned way is you watch the instructor do it, but really machine learning, data science, DSP, all of these are fields where it does not make sense to look at us do it. I know what I'm doing for the most part. There's always opportunity for, and I always keep learning, but really, how do I enable you to struggle with the stuff, especially since a lot of coding is really about debugging, right? So how do we kind of give you that platform to experiment with code, debug your own code, debug your partner's code, and build up these applications step by step in every codex by linking these various concepts that have math implemented into programming language, okay? So I've used this in multiple different classes. This is just the kind of ways that people interact. And I hope one of the things you're getting out of this workshop, at least in the trends component, is that what we think in the future stuff is going to look like versus what things we imagine they were based on the past. So one of the ways that we imagine students, or at least engineers, one imagined them doing was engineers, somehow there is this stereotype that, oh, in a real company, they're sitting in their own cubicle, they're working, they're coding away, and then they go have a presentation where they show their code, and then it's done. In the real world, it's more like this picture at the bottom, right? You are part of a team. You're building up code. All of these code segments go together. Your goal is to stitch together and also to work with the people to understand why did they do what they did so that you can integrate it into a more comprehensive project. So the effect of having codices written this way is that it encourages students not just to learn the hard skills of being able to write code that goes end to end, but also the important soft skill, which is how do you talk to people on teams composed of diverse groups of members so that you can all work together and accomplish the end goal, okay? So here are a couple of quotes about codices that students have had. You know, I've taught maybe about 1,000, 1,200 students this way at Michigan, at MIT, and various in-person boot camps across the country. Folks love the fact that unlike a textbook where you copy paste the stuff, here you really build things up. The conceptual questions and instant feedback that's punctuated throughout the codex. Most codices have on the order of 40 to 60 of these different assessments. They're really checkpoints rather than assessments because they allow the student to know, okay, do I understand what's happening before? And if for some reason I didn't explain it correctly, or there was a mismatch between what they thought they understood and what is actually out there, that's the time to be able to intervene and say, hey, call the instructor, teaching staff, and have an in-depth conversation about something instead of me as an instructor blarbing everything out from the beginning and hoping you get it when you're ready. Okay, so the perspective really, and there's two things I want to say. One is from the point of view of the author, this new era of higher education is about giving it to you when you're ready. There is an accompanying aspect of it that's very different in terms of what we expect from you as a student or as a learner, which is that when you are for a doubt, you have to ask a question. And that's really a perspective that I hope you see across all three of the talks in this session, which is that it's perfectly okay to get into the habit and practice of asking questions. Okay, I get confused all the time. I don't know what some of the things are. And in addition to knowing how to do things independently, it's also important to know that you're part of a team, and it's completely okay to ask people and your instructors for questions whenever you're confused. Okay, here are a couple of things related to how we did the class. They're not important. The point is, when we have codices written this way, or when you're an instructor or when you are trying to teach someone, you punctuate the codex this way, it's very easy to scale the class. And the reason you can scale it is because not everybody gets stuck at the same time. Okay, that's really the key point. People get stuck at different points and not all at the same time. So with a relatively small teaching staff, you can accommodate and have a lot of different conversations. And frankly, that is the best part for the instructional staff too. So when I teach using codices in my class, I love when people, if you would, ask us questions, because that's exactly at the point where they need that conversation in ways that are very different from the regular way where it is sage on a stage. So codices really are a way of enabling the flipped classroom. They're a way of sort of moving away from sage on a stage to guide by the side mode. And I hope you'll get to play with it too. And here's how you can do that. Okay, so if you go to the website, which is minerva.io/courses/register, you'll need to sign up. Once you sign up, there's a course code. You can enter Progress 2020, and you'll see a list of a couple of codices. There's going to be an intro to Julia 101, which is basically the Julia programming language, which is almost like MATLAB, but better in many ways. It's kind of the backbone for a lot of interesting machine learning algorithms. There's also going to be an intro to deep nets, so deep neural networks using Julia. It's just a part of it. It's to give you a flavor for how codices are written, and hopefully the experience of you going through the Codex makes it more immersive than other kinds of textbooks you've seen before. We love feedback, so if you go through this and you'd like to tell us more, you can email us directly at info@minerva.io, or you can email me directly. My email address, just to kind of say it, is at the bottom. I'm at UMich, so it's raj.nrao@umich.edu. And we'd love to hear feedback from you. And frankly, in creating these and using this to teach at the University of Michigan, my hope is that someday all textbooks are written in this immersive way that makes you feel connected to the author in ways that I hope you feel connected to what I've written after you've demoed it for yourself. That's all I have to say. If you have questions, again, please contact me offline. Thank you to the IEEE Signal Processing Society for this invitation. And I hope you're staying safe and well wherever you are.
Great. And now we're moving to the session on how to obtain research funding. And the session will be moderated by Professor Waheed Zubair from New York University of Abu Dhabi. Right?
Yes. Good morning and good afternoon to everyone, and good evening to everyone, depending on where you are. I'm pleased to be the moderator for this session on how to obtain research funding. I would like to thank Athena for this exciting workshop, and I hope you are enjoying the second day of the workshop. We are privileged today to host 4 panelists. We will start with Professor Woon-Seng from Nanyang Technological University in Singapore, and he's gonna be sharing his slides soon. Yes, please, Professor, you can start. Introduce yourself briefly and then you can go ahead.
All right. Can you hear me?
Yes. It's very
good. Hi, everyone. My name is Woon-Seng. I'm from the Nanyang Technological University in Singapore. And I think it's indeed a privilege to be attending this Progress conference and talking about this, how to obtain research grants in Singapore. So let me just get my, okay, hold on first. All right, so in this talk, I'm going to talk about some of the Singapore funding landscapes that you will see in Singapore. And in particularly, I will also talk about some of the Smart Nations activities that we are working on in Singapore, and to share with you some of this funding mechanism. All right. So let me just, something is wrong with my, okay, good. So let me get to the next slide. All right, so Singapore is a small country. We are focusing on a few research verticals, namely in the manufacturing and, let me get the power, the laser pointers, in the manufacturing areas and trade and connectivities, human health and potentials, and also the urban solution and sustainability. And of course, the areas that we're talking more is on the smart nations and digital government, digital economy. So you will see that the academic research is the horizontal that's supporting all these national verticals, and also on the training of the manpower to support the industry. So as you can see, we have different types of research grants listed over here, ranging from academic research funds to the more higher up in the competitive research program. So this amount range from 150,000 US dollars to around 7 million US dollars for a period of 2 to 5 years. So one of the highlights of this vertical is these Smart Nations programs, which I personally involved in. So Singapore is like is a city as well as a nation. Therefore, we call ourselves a smart nation instead of a smart city. So the main focus of the Smart Nations project is to solve existential challenges in living environments and commutes, daily transactions, and businesses through citizen-centric technology. So we, for examples, we have some of these bigger national projects, strategic projects shown over here in these slides, which is one of them is the National Digital Identities for citizens and business to transact digitally in a convenient and secure manner. We also have the e-payment to allow everyone to make simple, swift, or seamless and safe payments. So the one that we are working on is in the areas of smart sensors platforms, okay? And basically this is the deployment of some of the sensors and IoT devices that will make the city more livable and secured. And also we have this smart urban mobilities that's leveraging on data and digital technology, including AI and autonomous vehicles, autonomous vehicles, and to enhance public transportations. So there's also another horizontal called the Moment of Life, which is basically bundling some of the government apps or services across different agencies to make the citizens, to make their transaction easier and seamless, etc. So I will just go through some of the details on how research grants are being awarded in Singapore. I believe it has some of the common entities that you also see in Europe and US that you will hear from other speakers later on. So usually there is an open grant call of research in some thematic areas, such as in artificial intelligence, 5Gs, or some smart nation projects. So this is either an annual call or half-yearly call for letter of intents at the beginning, and then follow up by a research proposal. All right. So academic from both the universities and researchers from some of the research institutes can all apply for this type of grants. And the submission is through the respective universities, and there will be internal shortlisting process and by their own universities, followed by the funding agencies, and then they will have they will invite external experts to review the proposal, followed by a shortlist for interview. So the whole process, I would say, is range from 6 to 9 months due the award of these grants. So, but there are recently, they also have some urgent research grants, for example, the COVID-19 Research Fund. So this is a much shorter review process, and it awards the project much quicker in this manner. So the criteria for evaluations are mainly on the significance of the research, the potential of scientific breakthrough or disruptive innovations, and also on this program management and budget. So there's a listing of budgets and how the PI is proposing to use the funding for their projects, and also on the technical competence of the research teams. And ultimately is also looking into the potential impact and relevance to Singapore. So the approved projects mainly last for 2 to 5 years. All right, in between, there'll be interim review of the projects to the funding agencies, etc. So I would say in terms of success rate, is a similar rate of success between genders. Okay? There's not much of a difference. So there's another program that is particularly interest to this younger researcher. It's called the National Research Foundation Fellowships that provide opportunity to also to groom the young researcher to carry out independent research in Singapore over a period of 5 years. So it's all open to all the areas of science and technology, and outstanding young scientists and researchers of all nationalities are welcome to apply. So it's basically a two-step selection process comprising of shortlisting of process coming from applicants from all over the world each year. And then there's a selection, the final selection. Basically, in the final selection, the shortlisted candidates will be invited to Singapore for final review and interviewed by the fellowship evaluation panels. So it's mainly based on research track records of applicants. And the good thing is that it also offers a tenure track faculty position for successful candidates in the university and as well as in the research institutes. All right. So I have just one more slides just to share with you some of the genders differences in the disciplines and R&D in Singapore. So in terms of areas like computing, ITs, and engineering, the ratio of male students or male graduates is around 65% compared to the females of 35%. But when it comes to science, business, and accountancy, this ratio is reversed with 60% in females and 40% for males. So the university education and training, I would say, is around 50-50 in both male and female. But when it comes to research R&Ds and engineers, IT professionals, those working professionals, the ratio is around 70% as males and 30% are females. All right. So I think I will want to stop my presentation here by giving you these final slides. And if there are other questions related to this funding informations, I'm very happy to answer at the later part of this presentation. And if you need more information, you can always go to this particular link to find out more information on the different types of research funding and grants in Singapore. Okay, thank you very much for your attention.
Thank you, Professor, and very informative presentation, brief, but it gave us overview, high level. I have some questions here. I would like to ask, what are the efforts that have been done in order to encourage more females to join engineering, applied sciences? Because I am really impressed with the percentage compared to North America and Europe. This is close to 50%. If you compare this with engineering, you are averaging to 50-50, which is similar to what we are having here in UAE, United Arab. So can you comment, did this gradually increase, or it was always like this in the past 2 years?
Yeah, I think the ratio of the females graduates has been increasing over the year. I'm from the School of Electrical Electronic Engineering. So we used to have around 30% of female students, but now we are gradually having 40% intakes. I think it's the curriculums that students now, because of a lot of computing and IT stuff, the female students also prefer this type of subjects. And I think more students are finding them interesting. It's all about the curriculum. I think that they hear from the peers that this is a subject they are really interested in. And the good thing is that there's a lot of jobs in this area after graduates. I think in Singapore, we are quite pragmatic, and then a lot of students are looking for jobs opportunity in this area. So I would say that the female populations in the universities doing engineering stuff are increasing.
And how about the ratio within the faculty, like the faculty compared to 50-50? Is this reflected in the faculty in recruitment?
Unfortunately, it's not in the engineering departments. Or the female faculty members are much fewer. I would say maybe 10 or to 15%, especially in my university, in my school. So yeah, I think that is something that the university is trying hard to recruit females faculties to join.
Okay. And one last question: can you comment on like accommodating international scholars and scientists? I know that Singapore is very active with exchange programs, with sabbaticals. But when you have open positions, are there always a priority to the citizen of Singapore, or it's open to all nationalities, or depending on each university?
No, we all have a national. It's all national, so-called state universities in Singapore, and it's very open to foreign applicants. I would say that in certain areas we have more foreigner than locals in the university.
I see.
So you can see that our ratios are very international. Those coming from Europe, from US, etc. Yeah.
Okay. Great. Thank you, Professor. And of course, if we have any questions, please feel free to reach out to us and or to the professor on the links and his email. Thank you. And now we'll move to the next speaker and panelist, Professor Jutten from Grenoble, who's going to share with us the European research funding, presentation on European research funding.
Do you see my screen now? Do you see my screen, right?
Yes, the screen is clear.
Okay, so I will speak about European funding. I will present myself very rapidly. Now I am emeritus professor at University Grenoble-Alpes in France. But during the last 7 years, I was also in charge in CNRS, the National Center for Research in France, to prepare candidates for the ERC program that I will speak about now. So I prepare about 150 candidates during this year with proofreading, interview rehearsal, and so on. So I just change that. So what means ERC? ERC means European Research Council, and it's a pillar of excellence of the research in Europe. Mainly the other pillar correspond to collaborative research and research towards innovations. So this one is particular since contrary to most of the research program, it's individual grants for really excellent scientists. Mainly you have 3 domains, and of course the domain of interest for us is mainly physical sciences and engineering, but probably we can have also interdisciplinary research with signal processing part in life science or social sciences and humanities. Mainly there is also 3 categories according to your experience after...
Christian, we cannot see your slides.
Oh, yes, excuse me.
Appeared suddenly.
now you see?
Yes.
Yes, thank you.
Okay.
Thank you.
So I do like that. And there is, as I explained, it's really in 3 domains, and mainly there are 3 categories according to your experience with respect to your PhD diploma. So mainly for young scientists, it's between 2 and 7 years after the diploma. You have consolidator and advanced for all categories and of course older peoples. So who can apply? What is interesting is that any people for any country can apply here, and really it's based on excellence of the candidates and excellence and novelty of the project. The rule is that, of course, you have to do your research in a host institution, so mainly it can be university or other private institution of research in European Union or in associated countries. For instance, associated countries can be Switzerland or Israel. And you have to pass sufficient time in this country. At least 50% of your working time should be in European Union associated countries. So, as I said, that mainly it's based on excellence of both the candidate and the project, and some keywords in the ERC project is that it's to be high risk, high gain. It means that it is really high risk and new projects, but you have to show that the feasibility of the project is not zero. I believe that there is 2 points which are also interesting. It's a long-term project. It's 5-year project with a high funding. So it means that if you have a young researcher and you get a starting grants with 1.5 million euros, you can pay yourself on these grants, and you can also hire some postdoc and other PhD students for helping you and having your own team. Concerning the gender balance, the ERC there is an ERC working group for these issues, and there is a few decisions about that. First, for ERC, the main principle is that women or men are equally able to perform excellent research. And then you have a few decisions which has been done for promoting the gender balance at different levels. You can see the details in these web pages. And I would like also to mention that there is special condition for the maternity for each child that is born before or after the PhD. A female candidate has an extension of 18 months with respect to the period of time that I mentioned. For instance, for the starting grants, you have to have experience between 2 and 7 years. If you have one child, this delay of time is extended of 18 months. Here is a few statistics that you can find in more detail in these web pages. And it shows 2 things. Here, you have the success rate. So here for female and male in different categories, starting, consolidator, advanced, and the total. And here it's according to categories, and here it's according to the topics. Here is physical science and engineering. You see that the rates of female is a little bit higher for this category. That's the success rate of males. And on this figure, it's the evolution of the number of the percentage of candidates who are females. And there is some efforts at the European level for encouraging female candidates. And you see that from 2015 to 2017, there is an increase of the candidates. How to apply? I will go quite fast. Of course, what is important is to find your host institution when you have an ID. So it means that you need to be in contact, to be in touch with some laboratories for some people in Europe in a lab where you can do this research. And after doing that, you have to prepare your project and to see about writing your project. It's quite long. I give some detail in answering to some questions. And basically, I believe that the project requires many proofreading at different levels. And if you have also selected in the second part of the selection process, you also have an interview, and you need a lot of rehearsal for getting success to this part of the interview. As I explained, the first step in the evaluation process is done only based on a short presentation of your project. It's mainly your CV and your track record on the last 5 or 10 years, and a synopsis, 5 pages on your project. So this part of the project will be reviewed by the panel. The panel is quite large. For instance, in signal processing, the panel for signal processing is PE7. You have a very large audience of experts with, for instance, people in optical, people in electrical engineering like microelectronics and so on, as well as robotic, automatic control and signal processing. So it means that your project, your synopsis should be convincing for a very large audience, and you have to write such a project for a large audience so that you have to convince people that probably it should be very interesting to see more details in your B2. And the second step for every category is based on an interview with discussion in the panel and a presentation of your project. And of course, for this second step, it's really very important to make rehearsals for preparing this interview, and not only preparing your presentation, your talk, but also preparing a lot of possible questions and to be able to have short and convincing answers to these questions. So, as a conclusion, I believe that ERC project is really an excellent funding for any scientist of any place, any countries, and you can apply if you have a very good project and if you have already excellent records. I believe that there is also very important attention to gender balance, and of course, I think it's really a good opportunity after getting such a project, such a funding. You have a lot of chance to be kept as academics in the host institution where you will prepare your project. So thank you.
Thank you, Professor Jutten, and informative also about the European model for funding. I have a question. You know, one of the main challenges for any new faculty or any new academic, especially if she's a female, is to apply for funding and start to, because it takes experience to write proposals. And so is there a special program? I know that there is funding to support PhDs and postdocs, but is there a program dedicated for funding emerging scholars or emerging new faculty members in order to encourage them to join academia? Because if they are put in the same pool with the expert academics, it's going to be very competitive. So how you would comment on this?
So I don't know in every countries in Europe. In France, practically, I believe it's also due to the size of laboratories. Basically, laboratories, it's quite large laboratories. So it means that new faculty members are integrated in a team. And in fact, you can profit of some contracts that are currently awarded by this team. And you have time for preparing your academic duties, and then being able to ask for your own funding. Practically, you have perhaps in France 1 or 2 years before doing that. In some university, when you are hired, you have also small funding, perhaps between 500 to 10,000 euros for the 2 first year, for avoiding you to present, to write a project at the beginning, and especially since during your application form for being a faculty member, you wrote already a project. And if you want to develop your project, people give you this funding for instance, buying a computer, perhaps have a master students, and so on. Okay. Concerning the ERC, since it's based mainly for the younger people, it's between 2 and 7 years after the PhD. Sometimes people are still postdoc, and if you are very good candidates with good records, in this case, probably your supervisor of your postdoc can propose you to prepare such a project. And in that case, in most of university, I believe that in most countries in Europe, you have an office in the university which is able to help you in preparing this project, because it's of course very competitive, but it's also a very good spotlight of the university. The number of ERC grantees is really a mark of excellence. And all the university think that this very attractive funding, it's also very important for them, for their ranking and so on.
Mm-hmm. Very good. And do you think, what are the main, I mean, in any university, is like introducing the European funding model, is it now comparable to the national funding of each country? I mean, is it like 50-50 in most of the projects in any university? What is the percentage of funding from the union compared to, like in France, in Grenoble? How do you think funding from EU compared to the one from the French government or French research funding body?
So I believe that since there is also national funding, many people prefer to use the national funding because it's sometimes simpler. But it depends, in fact, of the categories and of people. But practically, the funding for the French agency is not very attractive, and sometimes the quality of the reviewing process and the success rate is not so good. So, of course, at the European level, especially for this ERC, which are based on excellence, it's quite competitive, because the mean rate of success is about 15%. So it's not so high. And there is also some selection. People make auto selection before applying. But I believe that it's really very attractive. And if you have a good background and very nice new ideas, it's really a good thing to do this proposal. What is also important is people who try to apply, who applied, but without success, they can recycle their projects and obtain other funding very easily. Because the way to think about future and not a very incremental project, but something which is much more innovative, it's really interesting for your career.
I have one comment, like I noticed that also EU funding supports projects under, for example, any institution in Europe, but it could be a remote campus. For example, in our case in UAE, we have the Sorbonne University in Abu Dhabi, which is linked to the main Sorbonne University in France. And also they are running projects funded by EU and European funding, although they are based in Abu Dhabi. So this is a really good model because it does not restrict you to a geographical area. As long as the PIs or the research team, some of them belong to the EU, you can, as you said, do your research anywhere in the world.
Okay.
Thank you, Professor Jutten. And now for this informative talk, now we will move to the Professor Deepa Kundur, and she is the chair of the Electrical and Computer Engineering Department in one of Canada's elite universities, University of Toronto. And she is gonna also give us some information about the Canadian model, which is from the main research agency in engineering, NSERC. So the floor is yours, Professor Kundur, and we welcome you to this panel.
Okay. Thank you very much. So I'm assuming you can all hear me right
Yes.
now? Okay, excellent. Thank you. Well, thank you very much for inviting me to this panel. I think we've had a very interesting set of presentations so far. So as Waheed mentioned, I'll be speaking about the Canadian funding system. So NSERC is the primary federal funding body, and it stands for Natural Sciences and Engineering Research Council. And so within that body, there are a variety of programs for faculty members for research, and they range in a spectrum from pure research to more applied research, or you can think of it as single PI research to research that looks at partnerships with industry. Because the value in Canada really also comes from being that tech transfer opportunity that exists that focuses on transferring the pure research results to something that can help the economy. Now, Canada, as with all countries, there are opportunities, of course, for funding from the provincial government as well as from industry, internationally or locally. But NSERC really is the main body for funding. Now, there are three main classes of funding possibilities here. I'm going to talk about the first one, which relates to the NSERC Discovery Grants Program. This is the pure research program, and I've had an opportunity to be chair of the Electrical and Computer Engineering panel for all of NSERC for a number of years. NSERC really focuses on distributing the funding overall based on geographic population and concentration of academics. So you tend to have higher funding given to regions with larger schools and a higher concentration of schools. Now, the spirit behind NSERC really is to develop talent. Okay, so this would be through graduate student training, for example, or undergraduate student training, to have research impact and to have and create this cycle within Canada of discover, innovate, discover, innovate. So it's the pure research and then transfer it to a practical area, and then more pure research and so on, and create really a vibrant science culture. So how do you assess something? A project that's going to do these kinds of things. NSERC has distilled it in terms of three criteria: excellence of the researcher, merit of the proposal, and training of highly qualified personnel. So this is PhD students, master's students, undergraduate students, postdoctoral fellows. And all three are equally weighted because they're considered to be equal contributions. So in terms of evaluation, we write a proposal, and I'll talk about how that, what that looks like shortly. We have a merit indicator table. And so people basically write a proposal, and I'll talk about the format of that. And it's evaluated by a panel according to these metrics here. So the rows correspond to the 3 criteria I mentioned: excellence of the researcher, merit of the proposal, and training of highly qualified personnel. And each application is put into one of 6 bins for each of these categories. Okay, so each person gets 3 ratings, ranging from insufficient, moderate, strong, very strong, outstanding, and exceptional. Okay, and then there's table discusses how that rating goes. So for purpose of fairness, and so this is, this progress workshop is really about diversity. And so there's a strong commitment with NSERC to enhance and promote an environment of equity, inclusion, and diversity. So this starts with the evaluation process, and this is how it's incorporated. And so there's a very strict way in which proposals are evaluated. Everybody on the panel is made to go through unconscious bias training so that they are aware of their own unconscious biases, and this can be, consciously addressed in evaluation of funding proposals. The discovery grant merit indicators, how we rate the different criteria, as I mentioned, are absolute. So we don't allow compensation in terms of stage of career and whatnot. And that is accounted for later on after there is an evaluation. And keeping things absolute also helps in terms of that equity. And established researchers and early career researchers are treated the same during this phase, but when funding them, we actually fund early career researchers with lower ratings than we would established researchers. So that's how we deal with it. And then we look really at these indicators to reflect the entire community. And so we also look to interpret them the same way over a period of a few years. Now, in terms of equity, diversity, and inclusion, okay, as I mentioned, this is a very strong value of the NSERC system, and it's also very, and when a funding body takes on a very strong posture with respect to the need for equity, diversity, and inclusion, it does naturally propagate to the academic institutions. So this has had a very positive impact, I would say, in Canada. So how, what do you do in terms of evaluating the ability of a proposal to enhance equity, diversity, and inclusion? Well, having a metric, and I showed you a table before, criteria, certain elements of the proposal are evaluated in terms of their ability to address EDI issues, okay? And so, this is especially evident in having to do with training of highly qualified personnel. So there is a training philosophy that in proposals people have to submit, where they're required to address an equity, diversity, inclusion, or EDI challenge in their field of research experience, and any specific actions that they are committed to implementing in order to address the challenge. Okay, so this is how it's essentially addressed. So it really gets the PIs to think about these things and implement them. Also, if applicable in terms of their research, and sometimes this is the case in the area of biomedical signal processing, biomedical engineering, applicants should also include EDI issues there. Okay, so in some areas, there may be natural issues of gender that need to be taken into account. So this is how it's integrated into the application process. There are a variety of evaluation groups focused on different areas. And so I have had the privilege to be chair of the electrical and computer engineering panel and on the panel for a number of years. And I just recently stepped down. And the evaluation occurs through a conference model. So we have members that I've highlighted in yellow, okay, and when we recruit members for that panel across Canada, and we have a few international membership, we do focus on a diverse panel. So we get different perspectives, diversity in all dimensions, in terms of research area, in terms of stage of career, as well as, of course, gender, race, sexual orientation, and other metrics. Now, a subset of these end up being what we call section chairs, and they help with the deliberation of each of the proposals. And then there's a group chair. And so for a particular application, we find 5 participants from this overall panel. And these participants tend to be reasonably close to the area of the particular application. And so we pick a subset of those. And then they're broken down into the first internal, who is closest to the area, the second internal, who's also closest, and they do an in-depth reading of the proposal. And then we have 3 additional readers who may look through the application, but not look through all of the materials necessarily. And then we have highlighted in red someone who moderates, called a section chair, the deliberations and keeps them on track and fair. Sometimes, if we have multidisciplinary proposals, we will even reach out to one of the other evaluation panels in a different area and bring someone else in as well. So we call this the conference model. Okay, and so as I mentioned before, there are the 3 criteria: excellence of the researcher, merit of the proposal, contributions to highly qualified personnel, and then there are 6 possible ratings for each one. And it is according to that table that I mentioned before. So one of the things is our applications have a variety of sections. And so this is true of many of the funding programs in Canada. And so the actual research proposal is about 5 pages, but there are other elements that are very important to be able to demonstrate the commitment to training, the philosophy for training, as well as past contributions. There's a CV portion as well. And so all of these sections are filled in, and the idea is you really do want to get the ratings in the fundable range. Okay, of that table. And so that's what we look at in terms of the goal of grantsmanship. Okay, and so this is, as I mentioned, the merit indicator table. The new thing that's been added as of a year ago is, if you look, and it will appear to be kind of a beige, the bottom row, there are evaluation metrics associated with EDI there that are important. And so my final points about the Canadian system is in order to enhance the equity of the evaluation process, we have a set of governing principles for evaluation. First of all, the onus on the applicant is really to provide all of the information. Reviewers can't give the benefit of the doubt, because this is where unconscious bias often pops in. Also, we encourage everybody to make it easy for the reviewers. So, you know, if somebody really puts a lot of time and effort into grantsmanship, it can result in a better outcome. Ultimately, in my experience on the committees, I would say that decisions are fair. They really are. We're finding that excellent applications come from a diverse set of schools and a diverse set of genders. And then there is recourse if somebody's not happy with their application results. And so a lot of times, if this occurs, we go through our process to make sure that things have been done properly. Thank you very much.
Thank you, Professor Kundur, for again another very nice presentation on the Canadian model. And its Canadian model is unique in a way is that because of my experience, I'm alumni of Waterloo, and I work with colleagues at U of T as well and other universities, is that I found that the diversity in terms of the number of countries where the students in the graduate body come from is really diverse, and this helps and is reflected in the faculty construction. So how would you comment on like the success of the Canadian universities or the Canadian higher education system in attracting international students compared like to other countries? I mean, when you ask anybody in the Middle East, you will always find that Canada is one of their preferred countries to go and for graduate studies. Of course, Europe will always be there and the USA, but Canada is becoming more popular.
Yes, I think it's, as you mentioned, it aims to be a very inclusive environment for research from multiple dimensions. Okay, so even in terms of research area. So I was in the US academic system for 10 years. So NSF, the equivalent, often has targeted programs with focus areas. Canada doesn't really have that. They leave, there's nothing really targeting a specific technical area typically. We look at the value of an application, without considering a focus area. And so for this reason, a lot of times what you see is an investment in research that may not be currently very hot. But the way Canada addresses that issue, that this really needs to be integrated in terms of tech transfer and be of use, is they have other programs that complement our NSERC Discovery Grant program, whereby partner funding and partner support, even in kind, is matched by NSERC. And there's degrees of engagement that they allow. So it's almost like a step process whereby there's parameters, we call it the Alliance program. There's parameters where something can be non-committal and result in a small term project. And after that goes well and that relationship with the industry partner or another partner is strengthened, you can go for something where both parties, both NSERC as well as the industry partner, invests more. And so there's a very nice gradual natural progression towards a very strong industry partnership. And this has happened to me in my own dealings with industry. We started with something very loose and non-committal, and over time, over a number of years, it really strengthened to an extremely efficient tech transfer sort of situation where true research, this isn't applied, true research gets to actually see some utility and exposure in an industrial or a utility, in my case, context.
One last question. What are the efforts at U of T, for example, in the engineering college for attracting more female to the faculty? I mean, do they have like a quota or a certain, or they get into the competition with the guys or the male faculty? Is there a special like positions for females to, because this is reflected in students when they see more female faculty, they will be more encouraged and inspired to go for engineering and applied sciences.
I completely agree. You said that very well. I would say of the many kinds of attractors of underrepresented groups, role models are essential in making someone feel that they can feel the confidence that they can take on the role and give them a sense of inclusion and resilience. So this is something that is a strong value of the university. So it's always important, I believe, if we need to diversify any sort of organization, that we're fair. And all parties believe we're fair. Okay, fairness is, and that's the ultimate goal. So when we evaluate applications, we focus on fairness. So we don't give an added, kind of bonus to somebody because they're from a minority group. But we do try and increase the numbers of underrepresented groups who do, across the board, take on our faculty positions, come to a study at the university in different ways. First of all, you can do it in the early stages, whereby you try and get a pool of applicants that's as diverse as possible. So you can put your efforts in targeting certain groups that have a lot of underrepresented members for the specific area, in our case, engineering. So we could look at women. We are very interested in indigenous members of the indigenous community, the Black community. And so we would advertise and actively recruit strong members. Then during the evaluation process, which is very consistent and fair, we often look at developing review criteria before we actually see applications, and we don't allow anyone to have a gut feeling, right? Gut feeling is where unconscious bias comes in. So after the evaluation process, we do invite them for interviews. And so we do train our faculty to make sure that nobody, is saying anything that may be potentially, and it may be well meant, but, potentially making an applicant or a candidate feel out of place. For example, we want to avoid faculty members giving any opinions to, for example, female candidates about whether or not they should have children, how they're going to manage. We do coach them not to do that. And then also when we bring them in and when we make an offer, I mean, as the chair, I think this is kind of one of the things I can bring, being from an underrepresented group myself. I think I can speak to them about some of the issues and really try to help recruit them and convince them to come to the department.
Okay. Actually, they will, I'm commending U of T, because having you in the position of the chair of the department is an evidence, of the support for minorities and for diversity, and this is really a good model, and it's like, showing the example in action, that they can see it for themselves. Thank you, Professor. And then we can also reach out to Professor Kundur if you have any questions. And then we'll move to the last panelist, respectful Professor Wan Lu from the Chinese University of Hong Kong.
Hello. So I would like to share my screen. Can you hear me?
Yes. We can see you, but we still haven't seen the slides yet. I can't hear you properly.
How about now?
Yes, we can see it now. Please.
Okay, good. So So I'll share a perspective from China, research funding. I spent most of my academic career in North America, so I'm familiar with the Canadian and US funding system. Coming back to work in China is a bit of a refresher in terms of research funding, because here the research budget at the national level, provincial level, and the municipal level increases annually anywhere between 5 to 10%. That's a bit refreshing. And also the high-tech industry is also booming. That gives a lot of funding opportunities as well. So I'll share some of these aspects with you in this short presentation. So the government funding comes from 3 levels: national level. This is a NSFC, that's National Natural Science Foundation of China, and also the Ministry of Science and Technology funds many large projects, TIM projects. Provincial research program very much mimics the national level, and then provides also matching fund to some of the national big grants. The municipal research grant program is perhaps the most generous one, because we're in the city of Shenzhen. Annually, the city hands out more than $2 billion research funding. So that's quite a bit of research funding for a young city where there are only 5 or 6 universities at this point. So, and then plus the industry, high-tech industries, a lot of global conglomerates really are pushing out, handing out a lot of research funding, and try to work with the university professors to do collaborative research. So that's basically the funding picture. Because of time, I'll just focus on the national level at this in the rest of the presentation. So the national level, there are 3 types of grants. One is the most popular one is the sort of research programs that promote basic research. This consists of general grant. It's like a NSERC or NSERC, just a personal grant, research grant. And there's also key project. There's a major project. There's a major research plan. So each of this differs by an order of maybe 5 multiplied by the research amount of funding. Each program, individual research grant, it's anywhere in the order of 120 or 150 thousand US dollars, and then multiply that by 5 for each of this. That gives you the sort of magnitude of the research funding that we're talking about. So that there are also various talent programs that funds young people, gives sort of especially targeted toward the young scientists. For example, if you are fresh in this funding picture, there's a so-called Young Scientists Fund. So this has an age limit. So if you're sort of fresh to this funding competition. You can, first grant you can get is for a Young Scientist Fund, and this is a so you compete against your peers, the same age group and the same research experience, similar research experience, and then the success rate is it's a lot higher. It doubles the general individual research grant. The general research program, individual research grant, the success rates are anywhere around 20%. The Young Scientist Research Fund, for example, for young people, it's 30–40% success rate. Some even for remote areas, there's also geographic preference. If you're coming from northern or remote areas like Xinjiang or Tibet, some of these places, you get even special research grants from those areas. And then there's also individual sort of a, it's like early career award in NSF. There's a National Science Fund for distinguished young scholars, and so on and so forth. There are quite a few of such research programs. And there are also third type of research program is infrastructure grants, which funds the big equipments and then also to develop research equipments, to build research equipment. So there are a lot of such big, usually we're talking about 15 million or 20 million US dollar kind of research project right now. So that's the rough picture of the funding instruments in NSFC at the national level. So a little bit more statistics. So the general program out of all NSFC, so funding is 66%. Actually, the funding goes to the general program, individual research grant, and then there are 26% funding goes to key program, key projects, and then the next category is the major research program and major research plan, and so on. So the allocation of funding within each research program in terms of so this is a key again the general individual program gets the bulk of the research funding. So there's a general coverage of research of researchers, like so each year, as I said, like 20% success rate. So a lot of people write proposals, and then the success rate it's around 20% these days. So that's the current breakdown of the funding ratio across different programs. Now, in terms of a diversity issue, especially the gender issue, unfortunately, only 6% of female researchers write research proposals as PI. That's sadly very low because in terms of female faculty members in my university, the Chinese University of Hong Kong in Shenzhen, we have 30% female faculty members in the university. In the science and engineering, in the university is even higher. In the science and engineering part, School of Science and Engineering, we have 30% female faculty members. But across the nation, but they all write proposals, of course, in our university, but only 6% of female researchers actually do write research proposals. This is a little alarming to me. And then only 13% of female members are on the research review panels. Only 13% of them are female. So that's also quite low. And then NSFC is trying to rectify that. And also most grants are awarded to male PIs, particularly the key program. This is the picture here shows you the breakdown. For the Young Scientist Fund, you can see the females get 41%, which is respectable. still lower than the male. But in the general program, and especially in the key program, the key projects, it's only like accounts for 10% or so of the total number of grants that's awarded. So that's so when the degree of difficulty gets increased, the success rate for the females gets also decreased quite a bit dramatically. And that's a sad situation. And then it's something that NSFC recognizes, and is trying to develop strategies to try to maybe help the female PIs to write successful proposals, get them reviewed. And in fact, in the whole review process, review cycle, the panel members, the guidelines for the panel members always, the guideline always says, if all things equal, female proposals, proposal from female PIs will have higher priority, will get funded more easily than male PIs. So this is written in every program that's funded by NSFC. So that's what I just said. In the review guidelines, female priority under the same conditions. If everything being equal, then female proposal from female PIs will win out. Also, in various age-limited programs like Young Scientists Fund or Excellent or Distinguished Young Scientists Fund, the age limit for women is extended to 40 as compared to men, which are 35 and 38 respectively, for this to qualify for the Young Scientists Fund and the Excellent Young Scientists Fund. So for women, that age limit is 40. That's another sort of a special preference for women. Female scientists also may extend their project term due to if they are pregnant during the research project, the time of the research project, or are given birth. So these are sufficient reasons to extend their project term. And also there's a graduate nowadays, a gradual increase in the number of female scientists on the review panels. This is due to the effort of the NSFC to try to rectify the gender bias in the composition of review panels. The application process, it's fairly, it's not surprising. The biggest difference I find compared to the North American system is compared to the US, it's really the two-stage review process. The first stage is peer review by sort of electronically. These proposal is sent out to some group of experts, typically 5 experts. They will rank these proposals. They give detailed comments, and then based on that, then you get a score. The proposal get a score, and then the proposals with sufficiently high scores, average scores out of the 5 reviewers will get to the next stage. Otherwise, they are basically proposal review process will be stopped for those proposals. So it's otherwise it's after that it's a review panel. The first stage is just anonymous review by peers through electronic sort of a system. So that's the two-stage review process, and then there's a timeline, and then the final decision whether to fund a particular proposal always rests with the council, NSFC council, and then annually there's one set of common deadline for the proposal. That's March 31st. But this year, due to pandemic, this has been extended. This deadline was extended by 1 month. So, so all the programs have the same deadline.
Sorry, Professor, just sorry to interrupt you, but
yeah.
Because the schedule is tight, so if you can wrap up, please, because...
Yeah, I'm done. I'm done.
Yeah. Great.
Okay,
Thank you.
sorry.
So I really thank you for this again informative presentation on the Chinese model of funding, and because of the limitation of the time and we have back sessions, if you have any questions, you can put them in the chat or contact the professor directly. I would like to thank all the panelists and all distinguished speakers for their time and for joining us from different parts of the world. And I hope you will enjoy the rest of the second day of the workshop. Thank you so much. Thank you.
Thank you, Waheed, and thank you to all the panelists for this excellent information.
Thank you.